In the previous video, when we discussed our gaseous systems, we typically talked about systems in which there was only one chemical species. But for many chemical processes that involve gases, you're actually going to deal with mixtures. Okay? Now, if you're dealing with ideal gas mixtures, so a gas mixture that would fit under the conditions of the ideal gas law, your pressure, the total pressure of the system, is going to be related to what we call the partial pressures of each of the chemical species. So P is typically assumed to be a sum of the partial pressures. Okay. So what I mean by that, mathematically, our P here, which is the total pressure of the system, is just going to be equal to the sum of all the partial pressures in the system. So here, partial pressure. All right. And so this equation that we have here is known as Dalton's law. And this is a very important equation. You'll see it all the time in this class. In fact, in chapter 6, we're going to use it quite a bit. Right. And so this is the case for ideal gas mixtures. But for non-ideal gases, it gets a little bit trickier. Right, and so as we saw in the previous video, when dealing with compressibility factors, in order to calculate them, we need to not only calculate the reduced temperatures, but we also need to figure out what the critical temperature and pressures are of our system. All right? But when we're dealing with gas mixtures, the critical temperature and pressure of our system, we're going to assume that we could calculate them as weighted averages of each of the individual components. So Tc and Pc are typically assumed to be weighted averages of the individual components. Okay? And so by that, what I mean is Tc is equal to the sum of the mole fraction of a particular chemical species in the gas phase times that chemical species' critical temperature. Right? And then it's the same thing for Pc. Right? So this sort of, approach is known as K's rule. And then once you calculate these weighted TCs and PCs, you would then estimate your compressibility factor by still using the compressibility chart. Ability